Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to talk about the root test. This is a test for convergence of series. It says if we have a series of a sub n, it's going to converge absolutely if the limit as n goes to infinity of the nth root of the absolute value of the nth term is less than 1. It'll diverge when that limit is greater than 1 or equal to infinity, and it'll be inconclusive when the limit is actually equal to 1. So let's take a look at an example. We're going to use the root test, if possible, to determine the convergence or divergence of the series. This particular series, you might notice, is actually a geometric series with a base of 1/5. So we should know by that it converges. But just for practice, we're going to try to use the root test on this. And the reason why the root test is a possibility is because we have an nth power, and the root test talks about taking an nth root. So let's go ahead and find the limit discussed in the theorem. So we're going to take the limit as n goes to infinity of the nth root of the absolute value of 1 over 5 to the n. Now, 1 over 5 to the n is always positive, so the absolute value is not necessary. So let's drop that. Limit as n goes to infinity of the nth root of 1 over 5 to the n is going to be 1/5, which is less than 1. So we can say that this series, n equals 1 to infinity of 1 over 5 to the n, converges absolutely by the root test. Let's look at another example. So we're going to look at n equals 1 to infinity, and we have 2 times, that's supposed to be an n, 2 times n over n plus 1, all raised to the nth power. Again, when you see that nth power, that's a clue that even if we didn't say use the root test, that it might be a good idea. So let's find that limit. So we're talking about the limit as n goes to infinity of the nth root of the absolute value of 2n over n plus 1 to the nth power. Okay, now 2n, n's positive, so 2n over n plus 1 to the nth, that's all going to be positive. So we can drop the absolute value. So we have the limit as n goes to infinity of the nth root of 2n over n plus 1 to the nth power. The power and the root cancel out, so we have the limit as n goes to infinity of 2n over n plus 1. Here we have a rational expression. The numerator and denominator have equal degree, so the limit as n goes to infinity is going to be the ratio of the coefficients, 2 and 1. So 2 over 1 or 2, but that's greater than 1. So that tells us that the series n equals 1 to infinity of 2n over n plus 1 to the n diverges by the root test. One more. Part C. Same instructions, use the root test if possible to determine the convergence. We have the series n equals 1 to infinity 1 over n cubed. You might recognize that this is a p series, and since the power p is 3, this should be convergent. Let's see what the root test concludes. So we are going to take the limit as n goes to infinity of the nth root of 1 over n cubed absolute value. All right, we can drop the absolute value because 1 over n cubed will always be positive since n's positive. So this is going to be the limit as n goes to infinity of the nth root of 1 over n cubed. And now, taking the nth root, I'm going to think of this as the 1 over n power. So this is the limit as n goes to infinity of 1 over n cubed to the 1 over n power. Raising each part, the numerator and denominator, to that power, we would have then the limit as n goes to infinity of 1 over n to the 3 over n. All right, so if you just think about kind of quote, plugging in infinity, you're going to have infinity to the 0 power. So that's indeterminate, but that doesn't mean it's not an indeterminate form that we could, for example, use L'Hopital's rule with. You have a little bit more work to do here. So I want to remind you that we've seen a limit like this before. So side note, whenever you have the limit as n goes to infinity of n to the 1 over n, we know this is going to be equal to 1. Why? Well, in the past, remember, we did the following. We said, let y equal n to the 1 over n. Okay, so what I'm going to do is I'm going to take the natural log of y. So that's going to be the natural log of n to the 1 over n. And that means that the natural log of y is 1 over n times the natural log of n. So what we're going to do now is we're going to take the limit as n goes to infinity of the natural log of y. In other words, the limit as n goes to infinity of 1 over n times the natural log of n. So this is going to be, we have a product here. You can think of it as a product of 0 times infinity, because as n grows large, so does natural log. But you can also think of it as limit as n goes to infinity, natural log of n over n, which would be infinity over infinity. And we could apply L'Hopital's rule. So that would be the limit as n goes to infinity of 1 over n, which is going to be the limit as n goes to infinity of 1 over n squared, or 0. So what we just found is that the limit as n goes to infinity of the natural log of y is equal to 0. But that's the same as saying the natural log of the limit as n goes to infinity of y equals 0. So if we're taking the natural log, or log base e, of some number and get 0, then that number has to be 1. So that means the limit as n goes to infinity of y is equal to 1. But remember what y was. Y was n to the 1 over n. So we have the limit as n goes to infinity of n to the 1 over n is equal to 1. Now, if we were to change this to 3 over n, by the way, the only thing that would change in our whole process here, 3 over n, we would have a 3 over n, a 3 over n, 3 over n, 3 over n. We would end up with a 3 here, a 3 here, a 3 here. It would still go to 0. In fact, you could have any constant over n in that expression, and you're still going to get 1 for the limit. So what that says is that this limit as n goes to infinity, 1 over n to the 3nth power is going to be 1. Now, that means that the root test is inconclusive. And not only that, but as I pointed out, it doesn't matter if it's a 3, a 1, or whatever. Anytime you have a p series to any power, the root test will always be inconclusive. So I'm going to say not only is it inconclusive for this, but it's inconclusive for any p series. So we don't want to use the root test on p series. Now, as I mentioned before, we do know that this series converges because it's a p series. The series n equals 1 to infinity, 1 over n cubed, is a p series with a power of p equals 3. And since 3 is greater than 1, then we know that this is a convergent series. But the root test won't get us there. I hope you found this video helpful. If you did, please remember to like it.